Hey students, in this video I'm going to go over 3 problems of our review. Just want to go over at least on each topic so you know how to do this review. The first 3 questions in the review are all about inverse variation. So I'll go ahead and do number 3. It says if y varies inversely with x, as soon as you see the words varies inversely with x, you want to write down to yourself the inverse variation equation. So y equals k over x. And then in class, we also discussed that we can rewrite this equation as x times y equals your constant, your k. So here it says that when y equals 8 and x equals 1, what is the value of y when x equals 4? So they are giving you already a combination of x and y. And that's enough information to use this equation and find your constant of variation. So we're going to do x times y, or 1 times 8, and that equals 8. That means that your constant is 8. Our equation to follow is y equals 8 over x. And then it says, what is the value of y when x equals 4? So what is the value of y when x equals 4? So we're just going to substitute a 4 in there for x, and 8 divided by 4 is 2. So the value of y is 2, and that's inverse variation. The other topic that you need to review is transformations of rational functions. And the anchor chart that we have on the Instagram page can help you with that. And here's a preview of it. You pretty much just want to follow what these variables do, the a, h, and k. A is the one that lets you know if it reflects over the x-axis and if it's negative. A also tells you if it vertically stretches or vertically compresses based on the value of that A value. And if we have H value that is negative, it will be substituting a negative value in there. So that will result in minus negative, which simplifies to the expression looking like x plus an h value. So it looks like x plus h, and it be shifted to the left. And the opposite will happen if it looks like x minus h, the shifting is happening to the right. The last one is the k value. That k is what shifts up and down. And if k is negative, that means it's shifting down. And if k is positive, it's shifting up. So for example, number 4, number 5, number 6, 7, and number 9. All of those are transformations. And for example, number 5. Let's do number 5. Number 5 has here, if you compare this to the parent function, we have a negative in the front compared to the parent function. We have a 3 on the numerator compared to the parent function. We have a 6 being added to that x on the denominator. And we have a negative 2 being subtracted on the function. So if we identify these and compare it to this format, we're going to notice that this is your h value, this is your k value. So h is going to shift it left and right, k is going to shift it up and down. That negative is going to reflect, and that 3, it's an a value that is greater than 1. So according to the chart and the notes, when a is greater than 1, it's going to be a vertical stretch. So that's one of the descriptions here. Vertical stretch by 3, sorry. And then we have a k value that's negative 2. So we, according to our notes, have a k value that is negative, that's shifting down. So that is going to shift down 2 units. So that's the other description. And then we have x plus h. So as mentioned, when you have an h value, but it looks like x plus h, we are going to shift left. So this one is actually shifting to the left 6 units. And this is just looking at the anchor chart, so you can always graph this in the calculator and compare it to the parent function to see how this movement happened. The last part is understanding that reflection, so it could be over x or y axis based on the descriptions in your answer choices. But technically, if the a value is negative, we will have a reflection over the x. If the b value is negative, we will have a reflection over the y-axis. So just keep in mind the anchor chart and your notes when describing transformations. The other topic that is reviewed in this handout is the attributes. So when we're finding the attributes, we need to look at the functions that they give us, and all of these in the paper are unfactored. So that's the first thing you want to do. You want to factor these. I'll go over number 11. Number 11 has a trinomial as a numerator. So we need to factor that trinomial. Whenever you factor, the first steps will be to find the GCF or ask yourself if there's a GCF. So you check all the terms and see if all of them have an x value that you can factor out. This one doesn't, so they don't have a GCF of x. Now let's look at the numbers, -2, -12, and 16. They're all even numbers, so we can definitely divide this by 2. Some students were wondering if the GCF is just 2, but I want to mention that if you divide this by 2, you're going to end up with -x squared, and we really don't want to work with an a value that is negative. So let's just take out that negative as well. So the GCF will be -2. If we divide each one of these by -2, we're going to have a positive 1, and then a positive 6x. So 1x squared plus 6x, and then a positive 8. We divided each one of these by -2. So this trinomial is the one that we're now going to factor. So when you have a trinomial, you want to, sorry, this is 4 terms. When you have a trinomial, you're going to use the strategy of the a times c and b to help you find those factors. So here we're going to do a times c, 1 times 8, that's 8, and then your b value is 6. So what numbers do you multiply to get 8, and when you combine you get 6? Those will be 4 and 2. 4 times 2 is 8, and 4 plus 2 is 6. So these are both positive. When you get these numbers, you're going to write down the factors, and you're going to have those numbers exactly the way they are. So x plus 4 and x plus 2. And you're going to divide these by the a value. The a value that you have here in this trinomial is 1. Don't look at this one. Look at the one you're working with for the x. So this one. The a value is 1. So if you divide these by 1, you end up simplifying this. 4 divided by 1 is still 4, and 2 divided by 1 is still 2. So that division of 1 technically doesn't do any changes, and those are the factors for your numerator. For the denominator, we're going to notice that it's also a trinomial. So same process, you're going to do an x, a times c, and b for that denominator. So 1 times 2, that's your a times c, positive 2. B value is 3, so positive 3. What two numbers do you multiply to get 2, and you add or combine to get 3? That's positive 2 and positive 1. Positive times positive is positive, 2 times 1 is 2, and then 2 plus 1 is 3. So these work. That means that your binomials here will be x plus 2 and x plus 1. And if we divide these by our a value is 1. So again, if you divide by 1, the numbers are going to simplify to the same number. So we just pretend like we are not doing any division, and those are your factors. I forgot to put that we took out the -2 on the numerator initially as a GCF, so I'm going to write it now, right there. So this is a factored form for this function. And now let's find these 4 attributes. So the wholes are found whenever you have the same factor on the numerator and the denominator. So you look for the same factor on the numerator and denominator. If you notice here, the x plus 2 is on the numerator and denominator. So we're going to use x plus 2 to help us find the whole. You're going to equal it to 0 because we're trying to find out what x value will give us a 0 as a denominator. So we solve for this equaling to 0 and we get x equals -2. So that is where you have a whole, when x equals -2. Next, we're going to do the vertical asymptote, and that is whenever you have the whole removed and you have a factor still remaining in the denominator. So you're going to look at here, we have the x plus 1 as the factor remaining. So we're going to write x plus 1 equals 0. And we're going to solve for when this equals 0 because we're trying to find out the other x value that will give us a 0 as the denominator. So you subtract 1 and x equals -1. So this will be your vertical asymptote. For the horizontal asymptote, we need to look at the degree of the numerator and degree of the denominator. Here, the degree of the numerator is a 2 for that little tiny exponent, and the denominator also has a degree of 2. And this is what we called a balanced comparison. They're both the same. When this happens, we need to convert or calculate actually the horizontal asymptote by having the leading coefficients on top of each other. Leading coefficient of the numerator over leading coefficient of the denominator. Leading coefficient of the numerator is -2. Leading coefficient of the denominator is 1. So we're going to write -2 over 1. And then we simplify -2 divided by 1, and that equals -2. So the horizontal asymptote is y equals -2. All right, the last part is to summarize this work with writing the domain. So we're going to write our set of x values such that x cannot equal, and again, you're trying to answer what x values you don't want to use to equal the denominator of 0. So we found out that when x equals -2, that will result in a 0 because -2 plus 2 is 0. So we cannot use -2. And then we also found out that x cannot equal -1 because if you put a -1 in there, -1 plus 1 will give you 0. So you also will have -1 as a number that you cannot use. And that is how you identify your domain. So these 3 topics are the topics you'll be tested on Tuesday. So try to review. Hope this video helps you.